Okay, so today we're going to look at Pythagorean theorem and how it works with tangents and circles. Okay, so we know that we learned already that if you have a tangent to a circle, it's intersecting exactly one place, right? We also know that if we have a radius that intersects the tangent at the point of tangency, we have a right angle. And we can also make right triangles by connecting more parts. Okay, so right triangles, if you have right triangles, then we can use Pythagorean theorem. So that's what we're going to talk about today, is how this kind of all works together. So here's my first example. I want to determine if this figure here is ST a tangent. I want to know if it's a tangent. If it is a tangent, then that would mean that we have a right angle right here. We don't know if that's true, right? We don't know if that is truly a right angle. And that's what we're going to figure out. Okay, so we know Pythagorean theorem is a squared plus b squared equals c squared. Keep in mind, c squared will always be my hypotenuse, right? The hypotenuse is always opposite of the largest angle, which is my right angle. So this piece here has to be my C, right? That has to be the hypotenuse. A and B can be either one of the other legs. It doesn't matter which one's which, because addition is commutative. It doesn't matter which one we designate as A, which one is B. All right. So let's plug in and figure out what we know here. So if we can use Pythagorean theorem here, if it is truly a right triangle, if we truly do have a right angle, then the Pythagorean theorem will hold. Meaning this will give us a true statement. So let's plug in A, B, and C. All right, so if A is 24, I have 24 squared plus B is 8, so 8 squared. I want to know, does that equal C, which is 25 squared? Yeah, I want to know, does that equal 25 squared? All right, so let's plug it in our calculator. So we have 24 squared plus 8 squared gives me 640. Is that equivalent to 25 squared? Which is 625. No, that did not hold true. The Pythagorean theorem did not hold true. Therefore, this is not a tangent. If we would have ended up with 625 equals 625, that's a true statement. So the Pythagorean theorem would have held, right? So that means it is then a right triangle, which means we would have had a tangent. Is that okay? All right, continue on with the Pythagorean theorem idea. We want to solve for x in this figure here. So we want to assume that all lines that appear to be a tangent are actually tangents. Okay, so they said if it looks like a tangent, it's going to be a tangent. So keeping in mind that my radius and my tangent form a 90-degree angle, that has to be my right angle. Which part has to be C? The 11 plus x? Right? This whole part, 11 plus x, has to be my C. The other two sides are going to be A and B. So we have x squared plus 14 squared equals the quantity of x plus 11 squared. Because we need the whole hypotenuse squared, right? Okay, so your algebra skills are going to come in here a little bit. So we have x squared plus 196 equals, now keep in mind, the quantity of x plus 11 squared is really x plus 11 times x plus 11, right? You need to distribute, or FOIL if you want to think about it that way. Okay, so x times x gives me x squared. Now let's do our outer and our inner. So x times 11 is 11x, and then the inner gives me another 11x. That's 22x. Then 11 times 11, 121. Okay, so we may have gotten a little nervous there because now we have an x squared and an x. But the nice thing is, what's going to happen to my x squares? I just have one x squared on each side. So by the time I subtract it away, they just become 0. Is that okay? So really, I have 196 equals 22x plus 121. All right, so now we can subtract 121 from both sides. I get 75. You're good. So you get 75 equals 22x. Divide by 22. I think it's like 3.4. Is it 3.4? Yeah, 3.4. So x equals 3.4. So these, a lot of times these do not come out nice and pretty. Sometimes they do, we get lucky, but a lot of times they're not nice. Questions on that one? It looks way more intimidating than I think it is, really. All right, you try the next one. The next one works just like this one. You go ahead and try that one. Would anyone like more time? All right, so for this one here, side C has to be x plus 18, right? This is side C. This is my hypotenuse. All right, so if we had x squared plus 24 squared equals the quantity of x plus 18 squared. All right, so I have x squared plus 546. No, 76, thank you. So plus 576 equals, this would be x squared plus 36x plus 324. All right, again, we got lucky because our x squareds are going to cancel. If your x squareds don't cancel, first of all, you could use quadratic formula, but you can do every one of these problems without having to do that. So I will try to look at it a different way, and you'll see that when you do the practice. All right, so if I subtract x squared, that's going to come up to 576 equals 36x plus 324. Subtract 324 from both sides, and you get 252. Divide by 36, I think you get 7. Okay. So you have x equals 7. questions on that one? All right. Last one. This came up on an air test a couple years ago. Something very, very similar to this. So I threw this on here. It says the CN Tower in Toronto, Canada has an observation deck 447 meters above ground level. About how far is it from the observation deck to the horizon? Okay, so let's figure out what they're even talking about here. So keep in mind, this is Earth, right? And there is this observation deck in Canada. You're standing at the very top, looking over at the horizon. Now, the horizon really it looks like it stops, right? But what's happening is the Earth is curving, and by the time what you can see, and then it disappears, it's because the Earth is curving around. Like you can't see curved, right? Your vision doesn't go curved like that. All right, so what we want to know is this distance from here to here. That's what we are interested in. Now we know that if we have a circle, and if a radius intersects a tangent line, we make a right angle. I can also then, that's the radius, right? I can also draw this radius in to connect with my tower. So we've created a right triangle here. Now another piece of information they gave us is that the Earth's radius is about 6,400 kilometers. So that means this side here has to be 6,400. Right, that's the radius of the Earth. Now this other part though, we have a radius plus a tower. Right, the other part of that triangle is a radius plus a tower. So this tower, they said, is 447 meters tall, while our radius is in kilometers. So do you remember how many kilometers this would be? Okay, it's 0.447. Okay, so we're dividing by 1,000 to put in kilometers. Go from meters to kilometers. All right, I won't tell your science teachers that. Okay, so now this missing piece of the triangle here is 6,400 plus 0.447. So this whole side here is 6,400.447. Is that okay? All right, so now we have a right triangle. So we can use the Pythagorean theorem. What side has to be my hypotenuse? The 6,400.447, right? So I would have x squared plus 6,400 squared equals 6,400.447 squared. Okay, so I don't want to write down what those values are, right? Because that's going to be a big number. It was bad enough to have to write all these zeros, right? So keep in mind, I would be subtracting 6,400 squared from both sides. So I would, in my calculator, automatically type in that 6,400.447 squared minus 6,400 squared. I don't figure out what 6,400 squared is. So I'm just going to type it in just like this. I don't want to figure out what the squared is ahead of time, because I don't want to have to write that huge number or round it or anything.
Could you just put 447 squared?
No, because keep in mind order of operations, exponents have to come before subtraction. Okay, so if I put that in my calculator, just as you see it there, you're going to x squared equals 5,721.799. Let's see, 809 kilometers. Well, I guess it doesn't really matter because we're still in x squared. So how do I find just x? Take your square root of that. So we get x is equal to 75.6 kilometers. So we're saying if you can stand on top or stand in the observation deck of that tower, the horizon, so where you can no longer see past that is 75, almost 76 kilometers away. So the math of that isn't hard if you can draw the picture. And remember that a radius and a tangent are perpendicular. Okay, I'm going to bring around the worksheet for you. I want to explain a couple of things to you so that you're not struggling needlessly. And then I'll turn you loose. So again, whatever you get done in class is fine. You do not have to do this for homework, unless you want to. All right. So a couple of things I would point out to you. On number 1 and number 2, you're just trying to figure out, do you have a tangent? Okay, but on number 1, it looks like this. Okay, so I want to point out a couple of things to you here. The radius in this circle is 10, right? This part of the circle is 10. You have to be able to transfer your radius to this section too. Okay, and it looks like it's always bisected, but it's not always the case. That's a coincidence that both parts of that hypotenuse ended up being 10. All right, so be careful of that. A lot of these problems you need to write in the radius. They only wrote it once, they didn't write it multiple times. If you look at number 2, radius ML there says it's 4.2. Well, LJ is also 4.2. So that 4.2 is only for that radius. Then look at another one. If you look at number 6, I recommend finding the entire side length of BC first. Because if you know the whole length and if you subtract the radius, then you have just that part left outside your circle. Okay? Otherwise, if you don't do that, you might end up doing quadratic formula on it. Okay? All right, so start on that. If you have questions, let me know. And then again, you don't have to finish it for homework, because I don't want you to have homework over break.